Hi friends, welcome all of you to my channel on ST1. Today we are going to solve a question from previous question paper October 2019 from T-beams. Here a question is given. A T-beam of flange width 1500 mm, that is given BF. You know the notation BF, width of the flange 1500 mm, thickness of the flange DF 100 mm, effective depth D is given as 500 mm, thickness of the web 250 mm, and area of steel 4 into 20 mm diameter, 4 bars of 20 mm diameter AST. These are the data given. In addition to that, the clear span of the beam is also given. Go through the question. L equals 5 meters. And what are the material properties given in this question? Grade of concrete and grade of steel. Grade of concrete M15 and grade of steel Fe250. Accordingly, the question is to find out or to calculate the maximum UD load the beam can carry. It's clear? We have already done questions to find out the moment of resistance of a T-beam. And here, in addition to that, we have to calculate the load also. What is the maximum load it can carry, right? So that's the difference between the previous questions what we have solved and this one from the question paper 2019 October. Okay. Now, what is the first step to solve this question? As usual, first find out the depth of neutral axis XU. Right, you know, XU is the notation for neutral axis. What is XU? XU is equal to, you know from the code, the formula 0.87 Fy into AST divided by 0.36 FCK into BF. Here B means width of the flange or breadth of the flange. Now all the data are given. Fy is given as 250 Newton per mm squared. AST is equal to 4 into 20 mm diameter. That means 4 into pi by 4 d squared. So you will get the area of steel divided by 0.36 FCK. What is FCK? You know the value 15 Newton per mm squared. Characteristic compressive strength of concrete into BF is the width of the flange 1500 mm. So substituting these values here, you can find out the value of XU. It will be equal to say 33.72 mm. You calculate and check. 33.72 millimeter is the actual depth of neutral axis of this beam. Now, to check whether the neutral axis lies in the flange or in the web, that we have to check first, you know that. So for that, find out the critical depth of neutral axis XU, critical or XU max for this particular grade of steel Fe250. What is the formula from the code? It is 0.53D. Previously, we had taken 0.48D when the grade of concrete was Fe415 HYSD bars. Here it is a mild steel bar Fe250. So the value corresponding to that grade is 0.53D, where D is the effective depth. That means 0.53 into what is effective depth? 500. That's equal to 265 mm. So the actual depth of neutral axis is 33.72 mm and the critical depth of neutral axis is given as 265 mm. Now we can compare both the values. Here XU is less than XU max. XU is less than XU max, and therefore what is the conclusion? It is an under reinforced section. It is an under reinforced section, and also the neutral axis lies in the flange. Why? Because we got the depth of neutral axis XU is equal to 33.72 only, but the depth of the flange or the thickness of the flange is given as 100 mm. So both the conditions we checked, the neutral axis lies in the flange and XU is less than XU max. It is under reinforced. Therefore, what is the moment of resistance? Now we can find out MR. The moment of resistance is equal to, what is the formula? 0.87 Fy into AST into D minus 0.42 XU. Okay? Or from the code you can take the formula that is given in the code. Both are the same, 0.87 Fy into AST into D into 1 minus. That formula you will get from the code, from the same annexure G. Page 96, I have told you, talked to already. From that, you take the formula and find out the MR. Moment of resistance. Here, Fy is given as 250 Newton per mm squared. AST is given 4 into pi by 4 into 20. That much mm squared. And D is given as 500 effective depth. XU is equal to 33.72 m. So using this formula, you can find out the moment of resistance. Calculate the values, you will get it as 132.7 kilonewton meter. 132.72 kilonewton meter is the moment of resistance of this T-beam as per the given data and material properties. Now, what is the question? It's not over. We have to find out the maximum load it can carry, maximum UD load it can carry. For that, what is the effective length or effective span of the beam? LE, the clear span is given as 5. So, what is the effective span? 5 plus, we have to add the effective depth also, that is 5 plus 0.5 equals 5.5 meter. For the design purpose, we should always consider the effective span of the beam. So it's equal to 5.5 meters. If we know the span, now we can find out the maximum bending moment MU in the case of a simply support beam carrying UD load. What is it? MU is equal to WU into what is the formula? L squared by 8. So that is 5.5 squared divided by 8. So this is the formula to find out the maximum BM. In the case of a simply support beam carrying UD load, we got the value as 132.72. So what is unknown here? The value of W, ultimate load, WU, the load is equal to 132.72 into 8 divided by 5.5 squared is equal to, when you solve it, you will get a 35.09 kilonewton per meter. It's the UD load. 35.09 kilonewton meter. Then we have to find out, what is it? The maximum UD load it can carry. What is it? The maximum, therefore, the maximum UD load it can carry equal to how much? 35.09 divided by partial safety factor, that is 1 divided by 5, you know that, divided by 1.5 is equal to 23.4 kilonewton meter. So that is allowable load it can carry. Even though we got the maximum load as 35.09 kilonewton meter, we have to divide it by the partial safety factor to get the allowable load the beam can carry. It's equal to 23.4 kilonewton per meter. So this is the method of solution when a T-beam is given with all the particulars including material properties. First to find out XU, compare with XU max and see whether it lies in the flange or the web, and check the section whether it is under reinforced, balanced or over reinforced, and after that find out the value of moment of resistance. From the moment of resistance value, get the value of W taking the maximum BM formula, and from that get the value by dividing it with the partial safety factor. I think it's clear to you, all of you, right? Okay, we will see you again in the next class on T-beams, another question. Okay, thank you, one and all.